Hello, everyone. Welcome here.
Good morning, good afternoon, good day.
Morning.
So welcome to this exciting webinar we've got today for you, where we've pieced together two talks that were shown at our FME user conference in Bonn, Germany last September. We had the privilege of seeing so many amazing talks, amazing speakers, and together the team and Elizabeth have assembled several that we thought we would share more broadly via this platform. And today we're in for a treat because we're talking about geospatial synergy, amplifying efficiency with FME and Esri. If there's one thing that we hope our customers achieve by using FME is that they get more of their time back. And so we were particularly intrigued by two of these talks that we've got today for you that are all about using FME in conjunction with ArcGIS technologies to make the whole workflow more efficient. And that's what it's all about today. By way of introduction, we've got a nice agenda for you. We'll talk a little bit about us, Save Software, then we'll hand it off to Jan Roggisch of Locus in New Zealand, who's going to talk to us about doing bulk data updates in ArcGIS Online and some of the efficiencies that were gained there. Then we're going to go to Australia, where James Botterill is going to talk to us about using Model Builder ArcPy within FME, which is a topic that I know I've personally been interested in for a very long time, and I'm really glad James is able to share this with us today. And we'll finish up with a bunch of Q&A, and along the journey, please ask questions. There's a bunch of us standing by to answer.
Great. And just quickly here, if you're new to Livestorm, you can ask those questions that you might have under the questions tab on the bottom right. And keep letting us know where you're tuning in from in the chat tab as well. And then if you have any audio or video issues, you can click that help button on the bottom left for 4 simple troubleshooting steps.
It's always lots of fun to see where everybody is, so thanks for sharing that with us, and we'll keep watching that. And the idea is that the sun never sets on FME, and it certainly never sets on our webinars either. So yeah, by way of introduction, we'll go to the next slide, Elizabeth.
And I'll just get us on stage to turn off our webcam so we can just save on some bandwidth for the remainder of the webinar.
Thanks, Elizabeth. Yes. We want to explore today the possibilities that happen when you combine the chocolate and the peanut butter, the FME and the Esri technology, to create something far greater than either one by themselves. And today it's all about getting efficiency when you're managing geospatial data. And it's so exciting to see how our speakers have assembled and created great value by bringing these two technologies together. So just a tiny little bit about FME. We are Safe Software, the makers of FME, coming into our 30th anniversary. FME just had its 27th, I think, birthday the other day. It's been around a long time too, but we've continually evolved that platform. So today we say we have one platform with two technology, FME Form that runs on the desktop, where the workflows you're going to see our speakers using are created and tested, and then FME Flow, where they are deployed so they can be run in response to stimulus like 3 in the morning and it's a schedule, or maybe a webhook fires, or maybe a file arrives in a directory. That's what FME Flow is all about. And Flow Hosted is our managed service where you can grab an FME Flow and let us look after the machine for you. So with that as introduction, we're going to hand it off to Jan, who's going to talk to us about optimizing bulk data updates in ArcGIS Online. Take it away, Jan.
Right. Hello, everybody. Yeah, it's really nice to be here today, and it's nice to see that so many of you have turned up. So, optimizing bulk data updates in ArcGIS Online. So, a little bit about myself. My name is Jan Roggisch. I am a GIS and system integration consultant and work for Locus. Locus is an FME reseller and professional services provider with offices and clients in both New Zealand and Australia. I've been using FME Form since 2007 and FME Flow since about 2014, and I'm certified in both. And like a lot of you on the call, I've been a long-term user of it and a very happy one at that. Right, what am I going to talk to you about today? First, I'll introduce the client that we did the work for. Then I'll tell you about the challenge they faced and how they went about solving parts of it. Then I'll talk about Locus's involvement and the solution we built. And then finally, I'll discuss a few takeaways from this project. Right, let's go. So the client was Auckland Council. First, let's look at Auckland Council as an organisation. It was established in its current form in 2010, so it's actually a fairly young organisation. It was created by merging 7 local councils in the Auckland region and extends far beyond just Auckland city limits. The total service area that you can see highlighted in the map here spans just under 5,000 square kilometres and has a population of 1.6 million people. And just to put that in perspective, that's about 30% of New Zealand's total population. They employ around 12,000 staff and have an annual budget of $3 billion. And all these statistics combined make Auckland Council the largest council in Oceania, which includes New Zealand, Australia, Papua New Guinea, and the Pacific Islands. Switching focus to technology now. Like most local government organizations, Auckland Council provides the public they serve with a lot of online tools, including location-based apps and services. They're using the ArcGIS platform for both internal and external GIS apps and viewers. And due to the wide range of work Council does in and for the community, a lot of the data sets published through these apps are all of the things that you see in this list here. So firstly, they're diverse, meaning they cover many different topics such as roading, three waters infrastructure, property, parks and recreation, and the list goes on. Many data sets are also complex. They might require extensive processing, especially if they are generated from multiple sources such as Council's rating database, asset management systems, including works management and service requests, financial systems, document management systems, and more. Some of the data sets can also be quite large. To give you just one example, in the Auckland region, there are more than 500,000 properties. And from what I remember, internally, the GIS team have a data set that actually has about 700,000 polygons in it. Finally, some data sets are quite dynamic, which means they may be updated very often. A good example is, once again, property data, which Council update daily so that public-facing apps, such as the service request one that I mentioned just before, are reliable. For instance, when people want to lodge a service request for a new property and things like that. A lot of services that councils provide are crucial for keeping citizens informed. And of course, GIS plays an important role here because maps are a good way to let people know where things are, but also the state of services. So for instance, you can communicate events like road closures really efficiently. So there's need for both scalability and resilience. This is particularly important during civil defense events such as natural disasters, which unfortunately Auckland has had its fair share of in recent history. An example are the 2023 Auckland anniversary weekend floods. You can get an impression of what this looked like in these pictures. So to sum it up, on the 27th of January, Auckland received an entire summer's worth of rain in a single day. It was around about 200 millimeters. The graph here shows accumulated rainfall at Auckland Airport for the years between 1963 and 2023, with the fat blue line representing 2023. And as you can see, that's way above what's ever happened before. This caused flash flooding and landslides in various parts of Auckland, which in turn led to several deaths and destruction of property on a significant scale. We're talking hundreds of houses and cars that were written off. To make matters worse, the following week, more rain led to more damage in the area. So why am I telling you all this? The point I'm trying to make is that Auckland Council is a large organization with a sizable customer base. They need to make web-based services available reliably and at scale. Even though the on-premise GIS worked well enough during the floods, Auckland Council's GIS team has an interest in looking for ways to make it easier to provide public-facing apps in a highly available way. The two main goals here are to build solutions that are performant, so they perform well regardless of the number of users, and that minimize downtimes due to system failure as well as maintenance. So the first steps they took were they explored hosting apps and app data in ArcGIS Online. Council is already using AGOL to make data available via the Open Data Portal, but they are also starting to make better use of AGOL's ability to host apps. That's a smart choice, of course, because it decouples public-facing services from Council's own infrastructure and its limitations. I'm mostly talking about planned and unplanned outages due to system maintenance here, because of course, all that just goes away. Platform as a service and software as a service cloud offerings usually cover the trifecta of non-functional requirements, which are scalability, resilience, and security. The last one will always need to be considered, but in this particular case, it isn't all that important because we're talking about public data published through public-facing apps. The good thing about ArcGIS Online is that upgrades to it are taken care of by the platform host, in this case Esri, and usually don't involve service outages, so straight away you have a much more reliable system. Now, that's a great start, but while this type of setup is great from an operational point of view, it does come with its own set of interconnected problems that need to be solved, and they're mostly to do with data updates. So firstly, updating large data sets takes time because, of course, you can't connect AGOL directly to your corporate GIS database that holds the most up-to-date information. Updating large data sets in the cloud can lead to service outages in the sense that even though an app might still be available, some of the data published through it may not be available for a while, minutes or sometimes more, while you're running an update, and that may not be acceptable. Secondly, updates need to be timed appropriately to minimize the impacts of the first problem. This means that updates need to be carried out at a time when usage can be expected to be low. That's usually late at night, and given the frequency with which some data needs to be updated, can mean a lot of after-hours work for staff involved. That's not great for them personally, but may also be unacceptable from an organizational point of view. And thirdly, Auckland Council, like a lot of other organizations, are running automated nightly data updates that refresh the on-premise master GIS database. Any external data stores, such as AGOL, that depend on these updates can obviously only be dealt with once the master data store has been refreshed. So, what can be done to work around the challenges that data updates in the cloud can cause? Council's GIS team did some research and came up with a really clever process that helps with part of this. They figured out that ArcGIS Online hosted feature layer views support switching between different data sources. The diagram that you see here shows how it works. You create two identical copies of a file geodatabase, or you use the same file geodatabase twice. You publish the file geodatabases as a hosted feature service, so that you have two identical services. They're they're called parcel updates A and parcel updates B. And then you create a feature layer view from the first service, in our case, parcel updates A. And at this point, you can go into the hosted view settings and change its data source to another feature service. There's a little video here that shows what this looks like in the ArcGIS Online web UI. We start on the view settings page, and you can see that the data source currently points to parcel updates A. We then go into update view, and on the next page, we select swap source. That'll bring up a list of hosted feature services available to the current user and allows us to choose the one to switch over to. In this case, parcel updates B. Once the new service has been selected, ArcGIS Online goes away and makes the change. This usually only takes a few seconds. When the process is finished, we can go back to the view settings page and confirm that the data source has been changed to parcel updates B. So you might have seen there was a little refresh of the map when I swapped out the data sets, and they just happen to be the same in this particular case. But this proves that the data source can be swapped or can be changed from one feature service to another. So I think that's a really cool capability with an AGOL, and it's one that I wasn't aware of before this project. When Council got to this point, they thought, well, this is great, but doing this manually every time isn't ideal. They wanted to take things a step further and automate the entire process so that instead of a person, all the hard work would be done automatically by FME. And that's where Locus comes in. Auckland Council approached Locus and asked us to help them automate the process they had come up with. The brief was fairly high level. They explained how things work in ArcGIS Online and then simply said, go and implement this whole thing in FME. And that is what we set out to do. The first question we needed to answer when Locus got involved was, how do we work out what to do? And that wasn't as obvious as it may seem. For anyone who works with APIs a lot, the first port of call is usually the software vendor's documentation. Now, I've done quite a bit of work with the ArcGIS REST API in the past, but mostly to manage data. So, for instance, read and write feature services, which is pretty straightforward, especially if you use FME's built-in tools for that. Even if you need to call the API yourself, though, it's pretty easy to work out what to do and then use the HTTP caller to do it. For this piece of work, I knew that we would very likely need to use the ArcGIS admin REST API. So I looked at the documentation of that first. Now, Esri's documentation is usually a great way to work out something that you haven't done before. But in this particular case, I quickly realized that it just wasn't quite good enough to get the job done. There was a number of reasons for that. It's not entirely clear which operation to use in which sequence. As you can see here in the image, most operations are available at both the service as well as the layer level, and that can be quite confusing. And then also, to be successful, our API calls need to include JSON objects that can be quite complex. And it's not always obvious which properties control which aspects or behavior of a feature, service, or layer. So generating these objects can be quite a challenge. Eventually, I decided that the best way to proceed would be to take inspiration from how people use Excel to automate processes. And what I'm talking about here is, of course, recording macros. So the web development version of that looks a bit like this. You fire up your browser and log on to ArcGIS Online. You open up the browser's DevTools, and then you work through the process that you're trying to implement manually while recording all web service calls. There are dozens of calls after you click the switch button, and most of these are to do with updating the ArcGIS Online web interface rather than making changes to data. You then have to work through each call and determine whether it's important for what you're trying to achieve or whether it can be ignored. Once you've whittled things down enough to identify the exact sequence of steps required to implement the full process, you need to work out what payload to send with each request. Now, there might be smarter ways of doing this than what I came up with, but I simply created a log of all request and response objects that were logged by the dev tools and then worked through them manually for each call to determine how to construct request bodies that would do what I'm after. So that's what this looks like. So this is the example of the first two steps. And as you can see, it's not particularly clever, but it actually worked quite well for me. The first version of the workspace took about 2 days to build, so that wasn't too bad. However, there were some issues with it. So for example, the process initially didn't honor field visibility settings defined in the view, but instead always mirrored settings from the underlying feature service. It also didn't retain custom settings for maximum cache age and always reset this to the 30-second default value instead. All of these issues turned out to be caused by mistakes I made either when pulling information or pushing updates. And after a few more iterations, everything was working as expected. Now, once we had it all working, we could split the overall job into 2 distinct steps. Number 1 is replacing the file geodatabase and updating the associated hosted feature service. You can see an overview of what this looks like here. There's a lot going on, but the basic pattern is make a call to the API to retrieve data we need, validate and parse the JSON response, then use part of it to prepare the next API call, either by populating a new JSON template or by updating an existing JSON object. To make everything work, I needed to make 7 distinct API calls and used every single type of JSON transformer available in FME, which, as a first for me personally, included the JSON updater, which was a lot of fun to work with. I also added a dedicated error stream that you can see here in the bottom right, that bookmark highlighted there in the right corner. And that was to make sure that we were able to collect useful information in case things go wrong. Given how much is going on here, something is likely to break at some point, at least during development. and then it's useful to have as much information as possible to figure out what needs fixing. So the actual error handling in this version of the workspace isn't very sophisticated yet, but it does collect errors in one place and could be extended to analyze and respond to specific errors in a smarter way down the track. The second distinct task is the data source swap itself. That's what you saw in that little video. This requires a very different set of calls to be made, but the patterns are very similar to the first step. Make a call, validate and pass the response, extract data we need to prepare the next request, then repeat until all work is done. To get this particular step done, 8 different types of API calls were required, and some of them more than once, where we work at the layer level rather than the feature service level. So because there's so much going on, we decided to manage and to an extent hide the complexity of the workspace by creating 2 custom transformers. And then they were plugged into a master workspace. As you can see here, it has a number of workspace parameters, but it's still a fairly small set that should be manageable when implementing this for particular feature service. Using our custom transformers as building blocks, the sequence we're implementing here is update the secondary feature service, then switch the view's data source over to the secondary feature service, then update the primary feature service, and then finally switch the view's data source back to the primary feature service. This makes the update flow as smooth and resilient as possible. The only thing that can really throw a spanner in the works here is if swapping of the data source fails. This will require manual intervention to be fixed. If anything were to go wrong during the update of the secondary feature service, the process would fail and the app would just show out-of-date information until someone can have a look and fix this the next day. And likewise, if the second update were to go wrong, as in the file geodatabase update, we would still have a functioning view. And in this case, we would actually have it with up-to-date information. So your apps would show the latest information to users. So it's been a very interesting project that had to go through a few iterations to get some of these things right because of the complexities involved in working with the ArcGIS admin REST API. And I've certainly learned a lot about ArcGIS Online, as well as some functionality in FME that I hadn't worked with before. I believe that the result of this is that we have fully automated data updates. Downtime, aka data unavailability, can be reduced to a few seconds from minutes or more. And it should only affect users that are zooming or panning right when the swap happens, the data source swap. And overall, this solution improves delivery of services made available to the public. And with that, thank you very much. And I think we are ready for questions.
Well, thanks so much, Jan. And yes, folks, if you have questions, put them into the panel now in the questions tab, and we'll be standing by to answer those, and we'll get right to them. But while that's going on, I think it's time for us to introduce our next speaker. And today we've got James from One Spatial Australia, who's going to show us how to use Model Builder with ArcPy inside of FME. And so, James, take it away.
Thank you very much to SAFE for allowing me to present again, following on from what was a great user conference. My topic today is demonstrating the way in which I used ArcPy geoprocessing, but within FME. So I will talk about the case study where we have a requirement from the government in Australia here to process some species distribution information, and I was to assess Esri versus FME approaches. So I'll show you how I utilized both of the tools and where I landed, and that is I ended up using ArcPy within FME. So to start with, I'd like to mention that Australia is home to some 600,000 or 700,000 species found nowhere else in the world, and 84% of these plants, 83 mammal, and 45% of the birds are very specific only to Australia. So the biodiversity we know is in decline, and today we'll be talking about the 1,700 or so ecological communities that are known to be threatened or at risk of extinction. Pictured here are the Carnaby black cockatoos. These flocks numbered once in the thousands around my hometown of Perth, and they have been in a worrying decline until recently. So, biodiversity. Here we have obviously our Australian government working in partnership with state and territory governments, non-government organisations, tertiary institutions and community groups to protect our native species. And this legislation is called the EPBC Act. And some of the requirements of this act require us to identify and list species of ecological communities that are threatened, amongst a whole lot of other initiatives. So this talk will look about how we examine the spatial listings of these threatened communities. A map says 1,000 words. Here is the 84 nationally recognised threatened ecological communities across 13 districts. These communities have been typically heavily cleared and fragmented into smaller patches throughout their ranges. So species of national significance, information on this EPBC Act. It has 5 also key attribute components: the community, the status, some kind of indicative occurrence, and that is obviously a spatial area, be it known or predicted that these species occur there. And for our raster processing here, we're going to talk to how we generalize the information to a 1 or 10 kilometre grid. More on that shortly. Why do we generalize? Well, we want to provide open data, but at the same time, we want to address concerns regarding the release of detailed information of these species, which can be sensitive to disturbance. So the information in terms of indicative occurrence has been coded in terms of a likely or may presence. Okay, so the government department here was seeking ways to improve their existing methods. They had automated Python scripts, but these are becoming increasingly difficult to maintain. And there were also additional manual checks and that had to be run regularly amongst a whole set of moving and complex business rules. So from only Python approach, they wanted to see whether or not FME could replace and support. In terms of the actual generalizing process, I drew up this diagram to sort of try to describe the way in which generalizing works, raster processing, gridding works in Esri or in FME. The key kind of decisions were what happens when there are overlaying or overlapping cells, how do we prioritize and rank? And Esri has extremely good functionality for that. And my job here was to assess whether or not I could build it into FME as well. So over to the right here, you see a little graphic of the actual distributions in their actual raw detail. This is a 1 kilometre grid processed and the 10 kilometre. So these were the 2 goals of processing and then eventually converting the data back to vector. So Esri gridding, for those familiar, this is the polygon to raster tool, and the key, very functional part of this is specifying the priority, which helped very much assign grids, particularly around some of the smaller occurrences with a high ranking. You want those to kind of be given more weight. So they yield the highest result by simply inverting the priority, which gave us a higher weight. And yeah, so this geoprocessing tool also has the ability in the environments to reference a snap raster. A snap raster is just a known grid, be it the 1 kilometre or 10 kilometre. And it efficiently uses that grid to create the raster output just for that area. A little bit more about raster grid referencing here. So the idea being that it snaps or aligns the extent. So you get a consistent raster grid each time you use this, and that sort of important when you're dealing with as many species and information quantity here. So, FME gridding, well, we tested alternative approaches. The numeric rasterizer creates the desired single band raster. There were some tricks to using it, such as preceding it with a 3D forcer to mimic the priority, which you specify as the elevation, and that helps to then follow up with a raster mosaicer and assign cells from there. So almost got the same result. Was able to use raster property extractor to also read a snap raster and kind of pass those attributes into the numeric rasterizer. But overall, the grids were a little bit larger and a little bit slower processing than geoprocessing within Arc. So, as well as needing a dissolve there afterwards. So this is sort of what it looked like from an FME perspective. And I guess the little learning or biggest thing here was my raster, which is in the top right-hand corner, ends up having quite a large extent. Whereas with the Esri processing, I was able to get the extent a lot more cut down to the data extent. And how can we perhaps find the best of two here? Well, I have used Esri in the past. I can't say I'm a proficient Python writer, but I can dabble. And here I'm just saving out of the geoprocessing as Python, straight out of ArcPy using the geoprocessing history. And I was able to then pass that into a PythonCaller. And my learnings here were, in order to do processing within feature processing within PythonCaller, you need the data set or the path to that feature class, as well as perhaps some other attributes which you can obviously create on the fly that help you orchestrate the full flowing to the PythonCaller. And yeah, after the processing has happened in the PythonCaller, you can read it back with a workflow transformer such as the feature reader. So this was the work in FME. You can see that I'm writing out different grids of different 1 kilometer, 10 kilometer, and then I'm setting up some attributes that I pass into the Python. So some of the key ones here, as you can see, reading dataset directories and giving rasters a name, the output polygon a name, because I actually do the raster conversion in Python and then I convert it back to vector. So here's a little snippet of what happens when you do these geoprocessing tools. I'm watching it live in the feature cache of FME. And in terms of Python code, the key bits are obviously you need to import Py and you need to pass in the other ArcPy functions of the geoprocessing. Prerequisites, you need to capture a license with the spatial analyst extension, set the geodatabase and ensure that it can overwrite, perform the vector to raster, passing in the parameters, and then I converted back to vector at the end. So some of the tips or learnings from my dabbling in Python, well, yeah, setting those environments and yeah, dabble a little bit with variables, working with the FME modules to capture the feature path to get attributes. I had some spaces in some of my file paths unwillingly, unknowingly, and obviously you can just use a simple replace for that in line within the Python. And I also found over time, yeah, using the log file object to concatenate attributes was pretty helpful because I could pass that back to some of the geoprocessing steps in runtime through to the transaction log in FME. So I knew when features were being rasterized and when they were being converted back to vector. Obviously, some data sets are really large in terms of their spatial distributions. So. And feature caching, you can't kind of leave it open the whole time, particularly when you're trying to override a geodatabase dynamically in a workflow. So perhaps emptying that and being a bit careful with partial runs to avoid some of these errors that are common. So in conclusion here, the overall workflow for the client involved a parent workspace that orchestrated which species had been updated and needed then processing given they had new distributions. And yeah, a child workspace actually did the geoprocessing amongst other things, where it was being generalized with ArcPy. And in summary, the ArcPy and Esri gridding functionality was the most consistent for the generalization requirements. It produced the right grids over that had in a similar way to that had always been created. Although FME proved pretty superior in terms of orchestrating the integration, it's very visual. And where FME lacks some of the Esri functionality, you can always incorporate ArcPy to do the geoprocessing mid workflow. And lastly here, get out and support your local conservation efforts in terms of the black cockatoo carnaby. They are indeed thriving now. We have action groups that have made artificial hollows in the environment because some of their previous habitat had been fragmented. So yeah, they now have hollows where they can nest and feed. So some of the resources I used today are listed here. I'd like to thank Department of Climate Change, Energy and Environment and Water, and also another big shout out to Safe Software. Thank you.
Well, thanks very much, James. Now I need to ask, how big is one of those black cockatoos?
Maybe 30 centimeters with their wingspan, pretty maybe 50 tops. Yeah.
Wow, pretty big. Yeah.
Yeah, they look magnificent. Yeah. For sure.
Oh, that's good. Great to see this. You know, it's one matter to have technology and, you know, you can get excited about rasterizing vectors and so on, but it's also really wonderful when it actually makes a difference to our world. And so thanks so much for presenting that. So again, folks, if you have questions, you can type them in and the teams will try to answer. But while that's going on, I'll wrap it up. So just want to thank both of our guest speakers, James and Jan, today. Thanks so much for what you've presented. And so now we'll just go ahead and look at some of the resources and next steps that are available. So you have our ebook. If you're new to FME or spatial data, you can grab our ebook that's called Spatial Data for the Enterprise. You can also go to the FME Academy, which is our newly redone environment for all things FME, tutorials, courses, and so on, all available there at the Academy. We, of course, have our knowledge base. Everything is really accessible through community.safe.com, so help yourself there. And of course, you're watching one of our webinars right now, but if you didn't know, there's an archive of all the old ones online at safe.com/webinars, plus the upcoming ones. And I know that Elizabeth has been working hard. We've got some interesting ones on the docket for the next 3 months. So please do take advantage of that. Of course, we'd love to hear from you. Contact us at info@safe.com. And lastly, if you haven't really experienced FME yet, you should try out the FME Accelerator. In 90 minutes, you get a nuts to soup, if that's a phrase, introduction to the whole platform. We give you a machine and an instructor walks you through trying out both FME Form and FME Flow, solving some problems live. So that's fme.safe.com/accelerator. And of course, Elizabeth, it just wouldn't be a webinar without a community badge. So tell us, what do they need to do?
So to claim your community badge, you can head on over to this short link. I'll leave it in the chat as well now. And then type in today's code, SGFLA. Yeah, and if you're not yet part of the community, definitely check it out. It's a great place to network with other users and lots of great resources there as well.
Yes, great.
All right, fantastic. And now we do have some time remaining for some Q&A. So if you have any questions at all from our 2 segments, please do leave those in the questions panel. But it's looking like it might be a pretty easy wrap up this morning. Not a lot of questions have come in. I think we got to the couple that came in through the chat so far. So yeah, we'll just give everyone a moment. And of course, as always, if you do think of questions after the webinar, we'll hang back online for a couple minutes as well and get to those in the chat as best we can. But yeah, in the meantime, while people think up questions, I'll just give a big thank you once again to our 2 guest presenters. We really appreciate your time creating this content for us today. And thank you to Dale and Natalie and Sarah as well for joining me on Q&A this morning. Thanks so much, everyone, and we hope you have a great rest of your day. I'll give everyone just a moment in case any last minute questions might be coming in. It looks like some folks are typing. Awesome. It looks like we might have one in the chat there, Natalie. I'm not sure if that's one we can address right away or one we might want to follow up on.
Yeah, the best way to have a good look at that particular situation when FME server or FME flow throws a license error like that is to likely submit a case to our support team, and we can do a deep dive into that with you at your convenience.
Perfect. Awesome. Thanks so much, everyone, for joining today. And like I said, we'll hang back online for a couple minutes in case any other questions come in. All right. Thanks, everyone. Bye for now.